Hey, so I was asked in an interview to implement a memoize function. That means that, for example, if you have a calculus of a method doing a calculus and it returns, let's say, 19, each time you call it, it will not pass through the calculation. It will return 19, of course, but it will not pass through the same expensive calculus inside the function, but it will return the result from cache. So I envisioned, let's say I envisioned like a demo scenario. Let's say you have multiply a with b, and then you have a multiply with b. So you don't want this to be called on the same input twice. And function memoize, which accept a function, and then you say, let's say, compute. Actually, C1, you want to do memoize of multiply. And then you have m 1 2 3, let's say 1 with 2, 1 with 2, and then you have let's say 3 with 2, but you have again 1 with 2. This should execute, this should write multiply, then multiply, but this shouldn't write multiply. This should give the result without going through this. So the way I stumbled at this question is, like, for example, I try to make a distinction of, hey, who's calling who. So first of all, by creating a function here, it's like creating a higher order function. So it's wrapping multiply in another function. So in this case, memoize has to return another function. So if you return just like this, and let's say console log memoize, and let's do this. We don't care about this right now. So we have memoize, memoize, memoize. So you can see it goes through this. But who is function? So if we look at function, we have the function multiply. So, but you might be tempted to say, okay, this is the actual function instance, but it's not. It's actually string is the declaration. So it's actually the declaration of the function. So here's where I typically get confused. But if you follow this structure, hey, I have to return a function, then you realize that your input are actually the coordinates here. So let's say this has only one coordinate, one argument. I'm sorry, argument. So in my case, it doesn't matter. It could be 1 or 2. So if you put args and then do something like fn call args, where you spread the args, you will have the result here. What we want to do, actually, let's return the result. Okay. What did I do wrong? Oh yes. So args. Yes, I need to spread here because here there are multiple. Arguments. And let's do some console logs just for you to see the result. Okay, I have none because what did I do wrong? Is this apply? No. Okay. So I have to call apply. So difference between apply and call is that apply, just apply, arguments provided as an array, and in call, arguments are provided individually. Right. So here we used the spread operator. Let's see how that works. Spread operator. The spread syntax. So allows an iterable such as an array or string to be expanded in places where 0 or more arguments. For function calls, exactly what we have. So we have a function calls. And you might be tempted here to use arguments. But arguments is actually the function, because here we have a shorthand function, and its context is based on this from the above, from here, from the context of the memoize. So you can't use arguments in here. That's the difference. Right, so now that we have the actual result here of the multiplication and we have all the parameters, now it's time to move on to the second stage where you actually want to memoize this. So memoizing is creating a cache. You can use map, object, whatever you are comfortable with, and the way you do this is, for example, I've chosen the hardest example, but you can choose whatever example you want. The idea here is that you have to pick a key. And for example, in my case, cache key is and will be, and let's see what we have here. So we have arguments, and I'm going to join them by a minus, for example. And based on this cache key, I will look in my cache, get cache key, and if I find something, let's say const result from cache. Actually, I could do this, let result. If result, then return result. Else, we call the function, but let's not forget that we also want to set this. We want to set the result. Okay, now let's do a, as you can see, it's already we're already calling multiply only twice. So you have 3 results, but we're calling it twice. But there's also a catch here that I think you can expand this to. So right now, let's say your assignment is ready, but what if the function is a different function? For example, it could be function add, right? And then you have add, but you have the same input. So if you were to do this on add, if you would share the cache, let's say if this cache would be global, you would have name collision in the cache key. So log cache key, because your cache keys look the same. So maybe if you want to go with the cache globally, you might want to also include here the function name. And I think somebody who is interested in you will consider this to be a very nice example of your attention to details, because then the key will contain as you can see, it will contain this function name as well. So we have multiply and add. So no more collisions. Let's see, A12 shouldn't add. So now you don't have collisions between the names as you could have had this. So you see multiply 1, 2, add 1, 2, add is no longer executed, and so on. So this is an implementation of memoize. Keep in mind that first you need to return a function from this, because a function returning a function is a higher order function. Thanks for watching.